Beneath the shimmering surface of our planet's tropical oceans lies a world of breathtaking beauty and complexity. These are the coral reefs, vast, living cities sculpted over millennia by some of the smallest architects on Earth. The builders of these underwater metropolises are tiny animals called coral polyps. Often mistaken for plants or rocks, they are in fact relatives of jellyfish and sea anemones. Each polyp is a simple organism, a soft-bodied sac with a mouth ringed by stinging tentacles. Living together in vast colonies, these polyps perform a remarkable feat of natural engineering. They draw calcium and carbonate ions from seawater to build a hard, protective limestone skeleton at their base. Generation after generation, as new polyps build upon the skeletons of their ancestors, the reef grows. But the polyps do not work alone. Their success is built on one of nature's most vital partnerships. Living within their tissues are microscopic algae called zooxanthellae. This symbiotic relationship is the engine of the reef. Through photosynthesis, the algae harness the sun's energy, converting it into food. They can provide the coral with up to 90% of its energy needs. In return, the coral polyp offers the algae a protected home and the compounds necessary for photosynthesis. It is these algae that give corals their spectacular array of colors. As daylight fades, the reef's character changes. Under the cover of darkness, many coral polyps extend their tentacles to feed. They are active predators, using stinging cells called nematocysts to capture tiny drifting organisms, like zooplankton, that pass by in the current. This nighttime feeding supplements the energy they receive from their resident algae. Though they seem boundless, coral reefs are geographically constrained. They occupy a surprisingly small footprint, covering less than 1% of the ocean floor. Yet, within this tiny fraction, they support an astonishing level of biodiversity. It's estimated that a quarter of all marine species depend on coral reefs at some point in their lives. From fringing reefs that border coastlines, to vast barrier reefs offshore, and the iconic ring-shaped atolls, these ecosystems are hubs of activity. The growth of a reef is a process of immense patience. Individual coral colonies may expand by only a few millimeters to a few centimeters each year. The colossal structures we see today are the result of thousands of years of continuous, slow construction. Some of the oldest living coral colonies are themselves several centuries old, silent witnesses to a changing ocean. Reproduction in this underwater world is just as fascinating. Corals can reproduce asexually by budding and creating clones of themselves to expand the colony. But once a year, in a breathtaking spectacle of synchronicity, many reef corals reproduce sexually. Cued by the lunar cycle and water temperature, entire sections of the reef release their eggs and sperm into the water column simultaneously, creating a blizzard-like effect that maximizes the chances of fertilization. A reef is not a uniform structure. It is a landscape of distinct zones. The shallow reef flat, closest to shore, endures fluctuating temperatures and light. The reef crest is the highest point, absorbing the brunt of wave energy. And the forereef slopes away into deeper, darker water, where plate-like corals arrange themselves to catch the last rays of sunlight. Each zone hosts a unique community of organisms, adapted to its specific conditions. The value of these ecosystems extends far beyond their beauty. For coastal communities, reefs are a critical line of defense. Their complex, solid structures act as natural breakwaters, absorbing and dissipating up to 97% of wave energy before it reaches the shore. This dramatically reduces coastal erosion and mitigates flooding during storms, protecting homes, infrastructure, and lives. They are also vital sources of sustenance and income. Reefs serve as a crucial nursery, providing food and shelter for the young of countless fish species. Healthy reefs support thriving fisheries that feed hundreds of millions of people and provide livelihoods for communities across the globe. The economic benefits continue with tourism. The allure of vibrant reefs draws millions of visitors each year for diving and snorkeling, generating billions of dollars and supporting local economies. When managed responsibly, this tourism can provide a powerful incentive for conservation. Furthermore, the immense biodiversity of reefs holds untold potential for medical and scientific discovery. Organisms found on reefs have already yielded compounds used in treatments for viruses and even in new painkillers. This field of bioprospecting is still in its infancy, and the secrets held within the reef's genetic library are priceless. But these invaluable ecosystems are fragile. They thrive only within a narrow range of environmental conditions. The most significant threat they face today is rising ocean temperatures, driven by climate change. When the water gets too warm for too long, the symbiotic relationship between coral and algae breaks down. Stressed by the heat, the corals expel their life-sustaining algae. This is coral bleaching. The coral's white skeleton becomes visible through its transparent tissue. A bleached coral is not dead, but it is starving and vulnerable. If temperatures return to normal quickly, the algae can return, but prolonged heat can lead to mass mortality. A related threat is ocean acidification. As the ocean absorbs more carbon dioxide from the atmosphere, its chemistry changes, becoming more acidic. This makes it harder for corals and other marine organisms to build their calcium carbonate skeletons and shells, slowing reef growth and making them more brittle. Local pressures add to these global challenges. Pollution from land, including agricultural runoff and sewage, can introduce excess nutrients that fuel the growth of seaweed, which can smother corals. Sediment from coastal development can cloud the water, cutting off the sunlight that the symbiotic algae need to survive. Plastic pollution and abandoned fishing gear can physically damage and kill corals. Destructive fishing practices, disease outbreaks, and population explosions of coral predators like the crown-of-thorns starfish can also cause significant, localized damage, further weakening the reef's resilience. Yet amidst these challenges, there is hope. Around the world, scientists, communities, and conservationists are working tirelessly to protect and restore these vital ecosystems. One of the most effective tools is the establishment of marine protected areas, or MPAs. These designated zones limit or prohibit harmful activities, allowing reefs the space to recover and thrive. Active restoration is also showing great promise. In a practice known as coral gardening, fragments of healthy coral are grown in underwater nurseries. Once they reach a suitable size, they are outplanted onto degraded reefs to help kickstart recovery. Techniques like microfragmentation, where a coral is broken into tiny pieces to stimulate rapid growth, are accelerating this process. Scientists are also experimenting with collecting coral spawn and encouraging larvae to settle in damaged areas. Responsible tourism plays a crucial role. Simple practices, like using mooring buoys instead of dropping anchors, never touching or standing on coral, and choosing not to feed fish, can make a huge difference. Even our choice of sunscreen matters. Some common chemical ingredients like oxybenzone and octinoxate have been shown to be harmful to corals. By choosing mineral-based sunscreens with non-nano zinc oxide or titanium dioxide, we can help reduce chemical pollution on the reefs we love to visit. And everyone can contribute. Reducing our carbon footprint is the most important long-term action to combat warming and acidification. We can reduce our use of single-use plastics, participate in local cleanups, and support organizations dedicated to marine conservation. Citizen science programs allow anyone to contribute to monitoring reef health. Coral reefs are at a critical juncture. They are a powerful symbol of both the fragility and the resilience of nature. They face immense threats, but they are also centers of innovation, collaboration, and hope. By understanding their importance, appreciating their beauty, and taking collective action, we can help ensure that these magnificent underwater cities continue to thrive for generations to come. The future of the reefs is in our hands. Coral reefs are a distinct marine biome. Warm, shallow, sunlit seas, where calcium carbonate builders create hard frameworks. Key abiotic factors shape them. Clear, low-nutrient water, stable salinity, temperatures around 23 to 29 degrees Celsius, strong light in the upper 50 meters, and wave energy that brings oxygen and removes waste. Where aragonite saturation is high, reefs grow. When it drops, growth slows. Though oceans are nutrient poor, reefs recycle efficiently, driving some of the planet's highest productivity per square meter. Biotically, reefs are layered food webs. Microscopic symbiotic algae are the primary producers. Herbivores like parrotfish and urchins keep seaweeds in check. Predators, from groupers to reef sharks, balance communities. Corals are ecosystem engineers and many species act as keystones. Reefs support food, livelihoods and coastal protection for over 500 million people and contribute hundreds of billions of dollars each year. Protecting herbivores, improving water quality, and expanding well-managed marine protected areas markedly boost reef resilience and recovery after heat waves.